Draw a scatter plot from the data that was given. Then determine if there was a positive, negative, or no correlation. For this problem, we've been given x and y data points. And we've been asked to see if there was a positive, negative, or no correlation. To do this, the first thing we want to do is graph all of our data. To do this, we need to take our x and y's and pair them up as ordered pairs, then plot them on the graph. I've already done this, but you can see how you can do this. You just take your x and your y, you put them together as an xy coordinate pair, then you graph it. Here we have 2, 3, so we plot that. And we continue that, so on, until we have all of our data plotted. Once we've graphed all of our data, the second thing we want to do is determine the line of fit for this data. So we want to take our scatter plot and find a line of fit. So we want to find the line that best represents our x and y data. The line of fit for this data looks something like this. Great. Now we have a line of fit for our data. The last thing we need to do is determine the correlation. To do this, we want to look at our line of fit. Our line of fit has a positive slope. So that means as the x values increase, the y values increase. Or as the x values decrease, the y values decrease. So our line of fit has a positive slope. That means that this data has a positive correlation. Draw a scatter plot for the data that was given. Then find the correlation. So we've been given a set of data as x and y pairs. And we're asked to plot the data, then find its correlation. So the first thing we need to do is to plot all of our data on a graph. Well, if we see, this has already been done for us. But if your data is not graphed, all you need to do is take your x and your y and pair them up as xy coordinate ordered pairs. Then all you need to do is plot them on your graph. So for the first one, we would have 2, 16. So we would plot 2, 16. Then we would repeat this process until we had all of our data graphed. This results in a scatter plot. Our second step after we plot our data is to determine the line of fit for the data. In other words, we want to find the line that best represents the relationship of this data. The line of fit for our data looks something like this. Perfect. Now that we have a line of fit for the data, the third thing we need to do is determine the correlation. So we want to see if this data has a positive, a negative, or no correlation. To do that, we look at our line of fit. Our line of fit has a downward slope. So that means the slope is negative. So as the x values increase, the y values decrease. Or as the y values increase, the x values decrease. So we have a negative slope. That means that this data has a negative correlation. Let's find the correlation for the data written on the board. If you've been given a set of data and asked to find the correlation, the first thing you want to do is plot that data on a graph. To do this, you want to look at your data and take your x and your y coordinates and make them into x and y coordinate pairs. Then you want to plot them on a graph. When you do this, you'll get a scatter plot. And for our data, our scatter plot looks like this. Once you have a scatter plot, the next thing you want to do is find a line of fit for that data. So we want to find the line that best represents our data on our scatter plot. The line of fit for our data looks like this. Great. Now that we have a line of fit, the third thing we want to do is determine the correlation. Now we can have a positive, a negative, or no correlation, and that will be determined by our line of fit. Looking at our line of fit, we see that it's a flat horizontal line. It's neither positive nor negative. That means that this line has a slope of 0 because it lies parallel to the x-axis. If you get a situation like this where your line of fit is flat or has a slope of 0, then that means that your data has no correlation. So that means that our data has no correlation.